Hi, my name is Braden Ganetsky, and I want to describe. I want to tell you all about the Boost.Describe library, where you can get reflection in your code today, not tomorrow. It's written by Peter Dimov, who is an amazing library writer. He is the author of Boost Smart Pointer, which was the inspiration for the standard smart pointers, so amazing stuff there. He's also the author of Boost MP11, which gives you type list metaprogramming with very simple syntax. We'll get into a little bit of that actually, but this presentation is about Boost.Describe. If you want to take a look at the code, here's the GitHub link. It gives you simple reflection of your classes and enums. And if you don't know what reflection is, I'll give you an example in just a minute. Boost.Describe relies on C++ 14 for the whole library, but actually most of it's only C++ 11. So if you're on C++ 11, you can probably use this library. So very powerful. And it only depends on Boost MP11 for the whole library, but similarly, most of the library actually only relies on standard C++. So very easy to use, very lightweight. If you don't know what reflection is, let's talk about that here. Here's a motivating example. It's usually the most common case of reflection. You have an enum, and you want the name of an enum value at runtime. So I want this toString function, this magic toString function. I want it to print out B if I give it B, etc. for all the types. Let's talk about how to implement this toString function. How are you going to do this? The simple way might be to switch on all possible values of the enum. And depending on what the value is, you give it that value as its string representation at runtime. And that works, but it's not very adaptable or extensible. Using reflection, you can get something that is very adaptable and extensible. So all I need to do with Boost.Describe is to register my enum with the library. So I call Boost.Describe enum on the type, and then I give it all the values. And after that, my toString function becomes a one-liner. All I'm calling is Boost.Describe enum to string with the runtime value. I give it a default just in case the value wasn't registered, but it's just a one-liner. And it's extensible, so if I change anything about my enum, I don't have to touch toString, and I don't have to touch all the other places I'm using the enum. And that's where reflection really gives you the power. Reflection is knowing stuff about your types so you can reason about it and make your code more general and extensible. Very powerful stuff with enums, but it's even more powerful with class types. So for this presentation, I want to tell you all about what Boost.Describe knows about your class types. And it knows a lot of things. I won't teach you all the different ways of how to use it and all that. If you're really interested, please check out the documentation. It is amazingly written. But I want to tell you about what Boost.Describe knows. And to start, let's talk about that it just knows the names of your members. So I have a simple pod struct. It's just a 3D point. And I want to register it with the library. So I call Boost.Describe struct with the type, with the list of base classes, and then the list of members. And after that, the type is registered with the library. And then I can do things, I can query different things about the names of the members of the type. So I'm going to use MP for each, which is from Boost MP11. And the reason is because Boost.Describe works with type lists, so it makes it very easy to integrate with MP11. So let's take a very quick detour to MP for each. MP for each, it's one of the functions of Boost MP11, and it allows you to iterate over a type list. So you give it a type list. Here I have A, B, and C. And then you give it a lambda. And what this translates into is calling the lambda on a default constructed value of each one of the types in the list. So here it's on A, and then B, and then C. So that's basically how that works. In Boost.Describe, describe members is an alias for a type list that gives you exactly what you're querying for. So in this case, I'm trying to get the public members of point, and then describe members returns to me that type list. Then the lambda is going to print out the name of each of the descriptors in the list. See, the type list gives me a list of descriptors. A descriptor as it sounds like, just has information about the member. So one of the things that it has is .name. If you want to know the other things, please check out the documentation. It's very well written. So let's get back to our example here. I want to print out the names of each of the members, and I'm doing it by using the Describe Members type list. So what will this print out? Well, you would expect X, Y, Z. And you would be right in expecting that. Now, one thing I will note, if you change the order that you register the members in Boost.Describe struct, well, then it prints out in that order. Okay, so Boost.Describe knows the names of your members. It also knows the difference between public and private. So this time, instead of using Boost.Describe struct, I'm using Boost.Describe class, which goes inside of the type instead of outside, and it has two additional parameters. First, it has the list of protected members, and then it has the list of private members. But similarly, if I just want to query describe members of A for the public members, well, it'll give me the public members. And if I want to print out all the names, it gives me I. Perfect. So it does exactly what I want. I can filter down the members on my type. That's really powerful. What if I want to filter it differently? What if instead of mod public, I try to type in something like mod private? Will that work? Oh, it does. Oh, look at that. Nice. So Boost.Describe allows you to filter down however you want. And if you want both, you can use mod any access, which gives you the public members, protected members, and private members. That's nice. But you'll notice you gave Boost.Describe the list of public members separate from the private members. So you gave it that information. Well, okay, let me show you something that you didn't give it. In this example here, in my struct of one data member and one function, when I register the struct, I'm not telling it the difference between a data member and a function, but I will prove to you that it knows the difference. So here, if I query describe members on B with just mod public, it implicitly says I just want the data members. And that's what it gives me, just the data members. But if I add on mod function, it does something different. It gives me the function members. And just like that, you see that Boost.Describe knows the difference. You didn't tell it the difference, but it knows. And that's really powerful. If you want both the data members and the functions, mod any member will do that for you. And there's a similar story from data members and functions with statics and non-statics. So again, when I'm registering this type with the library, I'm not telling it the difference between current and total. Well, one of them's non-static, one of them's static, but you register them the same. But I'll prove to you that Boost.Describe knows the difference. So similarly, there's an implicit non-static member when you call describe members with just an access specifier mod public. So here it gives me current. If I want the static members, I give it mod static, and that'll give me the static members. And again, Boost.Describe knows the difference. That's so powerful. It's incredible. You can use this with such versatility in your code. I hope you think of some amazing ways you can use this. If you want both the statics and the non-statics, again, you use mod any member, which does exactly that. Now you'll notice mod any member, it has a dual purpose. It overrides whether or not you have mod function, and it also overrides whether or not you have mod static. Okay, what else does Boost.Describe know? Inheritance, that's something we haven't talked about yet. So let's talk about that. Here in my setup, I now have two structs where one inherits from the other one. But if you notice when I'm registering D, well, I have to actually give it the list of base classes. And so I do that. One thing you might notice though, base and D, they both have a member X, and that'll come up in just a minute. So again, when I'm using my describe members type list, I'm querying it with just mod public on D. Well, it only gives me the members of D. It doesn't give me any of the members of the base classes of D, just D. But if I want the members of the base classes, well, that flexibility is there as well. So to do that, I use mod inherited. And with mod inherited, well, it gives me the inherited members. Sort of. What it actually does is it gives you the inherited members that aren't shadowed. Because X is a shadowed member, Well, it doesn't show up twice unless I want it to. See, again, Boost.Describe has this flexibility. If you want the shadowed members to show up, you can do that. You just have to add on mod hidden. And then the shadowed members show up. Now you have X and Y from base, and you have X from D. Okay. There's another type list that you might want to use. Instead of just grabbing the members of the base classes, what if you want a list of descriptors of the base classes themselves? Well, Describe does that for you too. If you want the list of if you want the list of base classes, you can use the Describe bases type list, and it will do that for you. Now, the structure of the descriptors are different from the Describe members type. So this time, I actually need to do a little bit of a different incantation to grab the name, but regardless, the functionality is still all there for whatever you want to do. In this case, I'm using MSVC, so it'll print out struct base. Great. So you can grab the list of members, and you can grab the list of base classes. I want to show you one more type list that Boost.Describe has. Let's go back to enumeration types for a minute. So back with my simple enum, with just A, B, and C, I want to print out something a little bit more complicated. Let's try like A equals 0, B equals 1, that sort of thing. Let's print that out. And to do that, I use the Describe enumerators type list. So with Describe enumerators, it gives you descriptors for the enumerator values. And that's exactly what it prints out. Nice. Okay, so as you can see from this presentation, Boost.Describe gives you a wide range of capabilities with very simple syntax, huge flexibility, adaptability to all of your code, and it's in C++ 14. So really, you have no reason not to use this library, and I really hope that you do. I look forward to seeing all the things that you create with this library, and thank you so much for watching.